So today we are starting with our plumbing class. Okay, plumbing class. So today mainly we will be dealing with just an introduction to our plumbing classes only. Okay, from tomorrow onwards we can deal with some of the core subjects or some of the important topics. Okay, so some of the students they might be writing notes. So I recommend you to write notes also. So some of them are in a stage of, I think some of them are working. So they won't be able to write it, right? So if there is a chance, if you can write it, okay, appreciate. So if you are not in a condition where you won't be able to uh, note down some points, okay, it's fine. So rather you just go through the video link that I am sending you, okay? So today, as I already said, I'll be dealing with just an introduction to the plumbing systems. So basically, we are, when we get a project, okay, when we get a project, usually the client or architect will be giving us the project. So the first thing that the architect gives us the drawings. It can be sections as well as it can be a plan drawing. So when we receive that plan drawing, suddenly we won't design anything. So first we will be studying it, studying the project, and we'll be just seeing the location, site locations in that drawing itself. Then after studying the site locations, we'll be raising an RFI. RFI means nothing but request for information, which means that we need some questions to be answered. Okay, which means that we be having some doubts. Okay, and that doubts will be created as a question, and that question will be sent to the architect or client. So when we receive that answers, okay, but for the questions that we have raised, okay, then only we'll be starting with the project. So initially, when we start with the project, we don't directly design anything. So as we are dealing with this plumbing, we have different systems. Water supply system is there, and water drainage system is there. These are the important two topics. Okay, water supply and drainage. So as we give the RFI, request for information, he will be giving back the answers soon. So when he given back that answers, we got all the answers for the questions that we have raised. So we will be starting with the calculation, the pipe calculation. Then we will be dealing with different tanks are there. For supply, there will be an overhead tank. Okay, overhead tank means the tank which will be kept in the top of the a building, whatever building it might be, for example, residence or apartments or hospitals or whatever it might be. According to that, the first thing is that we'll be sizing the tank capacity. We have to know how much liters of tank we have to put in there. Okay? And all those things will be knowing by the help of some laws or some numbers. Like in HVAC, we know that we have studied and we have we have followed an instruction from the ASHRAE, okay, American Society of Heating, Ventilation and Air Conditioning Engineers, Heating, Refrigeration and Air Conditioning Engineers, right? The same way in there are different plumbing codes like NBC, National Building Code, UPC, Uniform Building Code, okay, International Plumbing Code, like that different codes are there. So we have to follow their rules and regulations. Then only we will be able to design this. So what I am saying is that, so we have different calculations. We have to size the pipe, supply pipe dimensions are there, okay. In supply, there are cold water as well as hot water is there. Hot water system and as well as cold water system is there. So today I'm just giving an explanation, okay? Just an introduction for your understanding. We have supply as well as we have hot water. There are different methods for pipe sizing. Okay, Okay, as we have in HVAC, we have studied different methods for duct design. The same way we have different methods for pipes sizing also. Okay, like the main commonly used pipe sizing that we are using here is WSFU method, water supply fixture unit method. We'll take that all in the coming classes. Just I'm saying this. Then there is loading unit method, plumber chart method is there, to find the pipe size. The same way for hot water also we have to find the pipe size. Then comes the drainage. Drainage we have pipe sizes. So in coming to the supply itself, there are not only overhead tank sizing is there, underground tank sizing should be there. Rainwater harvesting tank size should be calculated. Okay, and we should be able to know how much is the minimum pipe dimensions for different fixtures. Fixtures means there are different sanitary fixtures. Okay, sanitary fixtures in the sense like water closet, lavatory, okay, like wash basin, shower, okay, all those things, urinals, etc., are commonly called as sanitary fixtures. These technical terms will usually be coming, okay, in plumbing, sanitary fixtures. Okay, so the NBC, National Building Code, or IPC, National Plumbing Code, will be recommending like this should be the minimum pipe diameter or minimum pipe size, okay, to different fixtures. Okay, according to that only we will be sizing it. Why we need to follow these rules and regulations? One is the safety factor, and next one is that whatever we design, for example, if you are building a home, you need water connections, right? So in some cases, we need approval from the local authorities. We need approval from the local authorities if you are trying to, build some building, or if you are trying to give some water connection, etc. like that. So when we design it, we should be concerned about the approval of it. So we have to follow some rules and regulations, and they will be checking the design with their rules and regulations. Then only they will be giving approval. So, like for example, in drainage, okay, we have different tank sizing, septic tank sizing, uh, wastewater pit sizing is there, soft pit sizing is there. Okay, all these are different tanks. Okay, and you know, there is a there are rules in which when we are trying to set the septic tank, there should be at least 8-meter difference from the drinking potable water as well as from the septic tank. There should be at least 8-meter difference. We are trying to give the septic tank which is near to your well or any water supply source. They won't accept that. And from not only that, from the nearby wall, you have to give at least 1 to 1.5-meter difference. Then only you'll be able to give these sorts of tanks, able to construct these sorts of tanks. Okay, and from the main road, this much meters, 3 meters approximately, that much should be, you have to leave. Then only you'll be able to give some tanks like that. So we have the what is the bottom line is that what I'm trying to say is that we have to follow some rules and regulations. Okay, and with that rules and regulations only, we when we follow that rules and regulations, and uh, when we design with that, we'll be getting the approval also. Okay, not only just for the approval, for the better flow, and for the better design and cost effectiveness and efficiency, we have to design it properly. Okay, so because that will affect every areas, even it will affect the client, the amount of money they are spending it. Okay, the durability, efficiency, all those things it will affect. So a better design is a must. Okay, so yeah, I was speaking about the supply, and supply there are two different things. One is cold water system, and we have hot water system. We have pipe sizing for it, and when coming to cold water system, in some cases we will prefer two tanks in the overhead. Okay, two tanks. One is a portable, and one is a domestic. Okay? Or we call it as domestic and flushing purpose. So usually we will be having underground tank like rainwater tanks, etc. So that will be not so pure waters. So what we try to do is that we will build a overhead tank and we will be subdividing it into two divisions. So we'll be getting two different tanks, right? So in one tank, you can pump it from your well. So you just imagine that the pump or the water from the well uh, is a pure water. You just imagine like that. Mostly it will be good water comparing with the rainwater. It's been stored in some tanks. And with the help of a pump, you can just pump it to the domestic tank, domestic overhead tank. And from the well, or not from the well, from the rainwater tank, you can use another pump, and you can from that water can be utilized and it can be stored in the flushing tank. So two tanks are there. So one connection from the flushing tank and one connection from the domestic tank you can take it. And this the water from the domestic tank, you can give it to the wash basin, shower, kitchen sink, all those areas you can give, and that from the water from the flush water tank, you can give it for the flushing purpose. Flushing purpose means uh, you can give it directly to the water closet because that is not much fresh water, not pure water. So we can utilize for that. Okay, the same way we can do it like that also, but rarely they will be doing like that. But still, people are preferring like that also in order to minimize the wastage of water. Okay, but if they have a common water supply system, they will be having only one overhead tank, and from the other water from that overhead tank will be given to both flushing purpose as well as for drinking purpose and for bathing purpose also. Okay, because they are using a fresh water. Okay, not only that, in all areas it is not necessary that the water even in the well is a fresh. So we have different the water purification systems. So we will be using RO filter, we will be using sand filter, carbon filter, iron filter, like that. Okay. So according to the need, we will be using different filters also. So the water will be pumped from the well or any tank, and it will be circulated through the water purification system. From that water purification system, it will go to the overhead tank. From that, overhead tank, the water will be stored as a pure water, right? Because it is coming through the purification, filter only. So from there, you can use it for different purposes, and you can keep the uh, purification plant or filter just after the pump, or you can keep the uh, purification plant or purification filter after the overhead tank also. You can use anyway, both the way. Okay, and mostly we are seeing that after this pump only from the underground tank or from the well only, we can keep it in the ground floor itself or on the ground level itself. Okay, that is the main thing. Now coming to the just I am giving a brief idea about all these things. Okay, then I will show you some slides. Okay, then after the water supply system, we can just see uh, about the drainage. Drainage. In drainage, that what we have to do mainly is that we have pipe sizing. Okay, and this drainage is divided into two or three parts or three areas where one is wastewater. Okay, wastewater is there. Then soil waste is there. Then rainwater. Okay, or storm water. We can call it like that also. So this wastewater means the water which is coming from the kitchen. Okay, and this water can be come from toilets, wash basins, shower, etc. like that. And soil waste means the water plus the solid waste coming from the water closet. That is a separate line. Okay. In some cases, they will be giving a single line also, but mostly they will be giving a separate line. Then comes the rainwater, the rainwater harvesting. So for your idea, I will just show an AutoCAD drawing. Okay. This is a this is, in this I have did the this is one of the drawing in Qatar. Okay, it's a big Toyota showroom only. So so this is a big Toyota showroom only. And the body paint roof. These are their architectural drawing. This is their architectural drawing only. In their architectural drawing, my concern was my job was to draw the rainwater drainage drawing. So you can see here. Okay. Okay. So just don't get confused or don't worry about all these things. So just I will show you just for your idea. Just imagine this is a block, okay? This is a D2 accommodation roof only. They have shown the slope here. This might be like a slope, okay? The roof will be like a slope. So when the rainwater will be on the top, it will be flowing and it will reach in somewhere here. This is the rainwater outlet. From here you can get the water and through this pipe. This is a collection chamber, okay? It's a collection chamber. The water will be collected in this chamber and it will be flowing. And this is the uh, manifold. Okay, whatever it might be, we just initially have to connect it to a collection chamber. Then it has to go to manifold. Okay, and this manifold, depth is very large. Okay, in this case, we almost we go to 3 meter height like that. So from there, this is another connection. This manhole to manhole, there is a connection. Okay, this is a manhole to manhole, there is a connection. From here, there is a collection chamber, and you can connect to this collection chamber. Then we can give it to here. So you may ask why you can't give to this directly to this pipe. Okay, we can't give like that pipe because this pipe and as well as this pipe is in a different level. Okay, this line to this line, okay, it is going below 3 meter level. It is going like that. This is very sits in the top. So it can have a maximum 1 meter or 1.3 meter like that height. Okay. So you cannot directly touch this because this line might be going in this level, and this line might be going in this level. So you cannot touch. You cannot link this both. Okay, and you can link to this line to the manhole. And this is like a manhole. This line will be reaching the top of the manhole. Okay, then it will be coming into the manhole. So I'm not just confusing all those things. So just for your idea, then it will be going into the rainwater holding tank. Okay. So this is just for your idea only. This is not enough for a drawing. Okay, you have to mark what is the invert level, what's the pipe dimension of it, how much is the invert level. Invert level means how much height it is being, the water or the pipe is going. I'll show you how it will be. It will be like this. You have to mark it. What is the diameter of this pipe? What is the pipe you have used? What is the slope? What is the invert level in which it is entering into it? Okay, 7.10 meter. Okay, and this is storm water manhole 15. Okay, and what is the pipe diameter of this 100? The slope 1:100. Okay, all these things we have to mark it. So, so first we will be giving a drawing like this only. Okay, and this is the side drawing. Okay, this is the side drawing. And first we will be studying about it, and we may have many doubts regarding this. So that's what I said. First we will be raising an RFA, and we will be asking many questions to it. Okay, can we give this water tank, or can we place a soft pit instead of this rainwater tank? Okay, all those things, different things we'll be asking to it. Okay, finally when we get that answer, we'll be trying to draw it, design it. So, so there will be different lines will be there. Okay, so this line shows the rainwater, and this line shows the hot water or like drainage or something like that. Okay, so it should not, it should not get interfere with this block. That's why I have marked like this. See, this both are getting connected. That is, we cannot do like that because this is one chamber and this is another one chamber. This both cannot link. So we have to change according to that. That is what it is called as coordination drawing. So when we try to do this, it should not, affect any other, pipelines. So just I'm leaving that. And then coming to the plumbing training, okay, just explain from here. So coming to the introduction part, first we have common sanitary and modern plumbing fixtures, layout of sanitary fixtures in toilets. Which means that first we'll be studying about different sanitary fixtures, like what is water closet, lavatories, wash basins, toilets, bathtub, showers, okay, kitchen sinks, dishwashers, different sanitary fixtures are there. Okay, and when we are dealing with this, you may ask what is the purpose of studying all these things. When we are trying to give water supply to this, we should be able to know how much height the water supply should be given. So for a water faucet, this much height from the floor you have to give. Okay, from wash basin for the pipe connection or for the wall connection, from the ground floor for the finished floor level, you have to give this much height. For when you are dealing with showers, there is a height. Okay, so depending upon that water closet, that area, that height should be this much. There is a proper dimensions are there, proper heights are there. Okay, so we have to know about that. Then we'll be studying about formula for flow through pipes. In this, we'll be studying about different formulas. In coming classes, we'll be studying about different formulas like Darcy's, Chase's, Manning's, Hazen-Williamson formula, Reynolds number. Why we need to study all these formulas is that with the help of these formulas, we'll try to solve questions. And in order to, when we solve the questions, we can find the slope, we can find the frictional loss, we can find out the pipe diameters. Okay? And all those things we can find it out from these formulas, and we can find whether it is a laminar flow or turbulent flow with the help of this Reynolds number. If the Reynolds number is going beyond a particular number, you can call it as a laminar or a turbulent flow. It is coming below that number, you can call it as a laminar flow, or it is coming the Reynolds number is coming in between two range, you can call it as a transition flow, etc. like that. Okay. Then I was explaining about the water supply system. So direct systems are there, pump system is there. So direct system, in the sense, what you mean by that is, normal thing. Like just imagine of this. Okay, I'll give a brief idea about that. We are constructing a house. We need water connection for a house. Okay. So I have a well and I have a underground tank also. Okay. The first duty, so you have to keep this in mind. The first thing is that I have to pump the water from my well and from the underground tank to overhead tank. placed on the top of my house. So that water has to reach to the overhead tank. Okay, if you get what I'm saying today, it will be very easy for you. Okay, so you listen carefully. Okay, so that water from the well has to reach to the, so the water from that well, if you reach to the overhead tank, what I have to do is that I have to place a pump. Okay? With the help of that pump only, I will be able to, get the water and able to supply it into the or discharge it into the overhead tank. So first, I need to know the pump capacity. If I know the pump capacity only, I will be able to keep that pump. Okay. So pump capacity calculations are important. The next one, there's a proper pipe dimensions. Okay. There are different pipe dimensions that we will be studying, like 20 mm, 25 mm, 32 mm. There are standard dimensions of pipe. Okay. So we will be choosing an appropriate pipe dimensions. Okay. It can be 32 mm or it can be 25 mm pipe diameter. Okay. So water supply, there won't be any change in the water supply pipe dimensions. Main supply pipe dimensions. You can choose when you buy a pump and motor. The outlet and the inlet pipe diameters will be mentioned there. 25 to 25, 25 to 32. Okay, 32 to 32 mm. It may be not like that also. The pump is there. At the one end of the pump, there is a there is a valve. Okay, and from that valve, there is a pipe, and from the pump there is an outlet. From that outlet, you will be able to discharge it into the overhead tank. Okay, so you need a pump. So once the water from the well and from the underground tank, you just pump it to the overhead tank. The water will be stored in the overhead tank, right? So that valve is known as, the valve is known as foot valve. Okay, the foot valve. If you are using a centrifugal pump, there will be a foot valve. There are different types of pumps also. Okay, you can use submersible pump. You can use centrifugal pumps also according to the applications that you are trying to do. If it's a borewell and all, water, you can use submersible pumps. Okay. So yeah, the first step, the water from our well and the underground tank, it reaches to the overhead tank by the help of a pump. Now, from the overhead tank, it has to supply to our individual fixtures, correct? Like shower, wash basin, taps, sink, kitchen sink. Okay, all those areas we have to send it. So we need a pressure. Okay, there should be a pressure, in the pipe. Okay, there should be a pressure in the pipe. Or there should be a pressure in the for the water. Okay, so when you are trying to keep the overhead tank on the roof, in a direct system, the pressure won't be sufficient. Okay, they are directly keeping it on your roof or the terrace. Just imagine it is a single-story building. Your house is a single-story building. On the top of your house, you are just trying to keep it on the terrace. It's not necessary that you will be getting a sufficient amount of pressure in your fixtures. When you open the tap, it will be coming very small. It's not coming in very high, in a good pressure. At least you need a 2 kg pressure. Okay. So what you are trying to do is that you have to keep the overhead tank. You have to keep the overhead tank in a raised level. In a raised level in the sense, you have to keep some stand. You have to keep a stand, at least a 3 meter height stand. On the top of that, stand only you will be keeping the overhead tank in order to make sure that you will be having a correct pressure, because this water is going by the help of a gravity only, okay, in this case. So it is going by the gravity. So in order to get the correct pressure in your fixtures, you have to elevate the overhead tank so that we can get a proper pressure to the individual fixtures. Understood? So in when we deal with some projects, but when we are really dealing with this, residents and all, the client will say that I don't want to keep, a stand. I don't want to keep a stand because that will affect my aesthetic view. Okay, so some client will be more concerned about their view. So if you are looking from outside, if a person is coming to your house from outside, if they see an overhead tank on the top of your your house, they won't, they don't want to see that. They don't want to see that overhead tank. So from our concern, we need pressure. From his concern, he don't want to see that overhead tank in a raised level. So what we have to do? We have to shift it to another options. Okay. What is another option is that we have to give a pump setup, or we have to give a booster pump. So in a case, if there is no sufficient pressure, or if there is if we can't get a sufficient pressure, we can give a booster pump after the overhead tank. Yeah, from the overhead tank. So if you are keeping it on the ground also, ground in the sense if you are keeping it on the terrace also, without the stand, if you are using a booster pump, that is fine. You will be getting correct pressure. You are okay. So first we have dealt with the water from the well and the underground tank. We have pumped by the help of a pump to the overhead tank. From the overhead tank, by the help of a water supply connection, it has to reach to individual fixtures, sanitary fixtures. Okay, so we have to keep it in mind that we need a proper pressure. Okay, we need a proper pressure, and if we cannot get a proper pressure, we can use a stand. If that is not allowed, we can use pressure pump or a booster pump. Okay, from the overhead tank to the individual fixtures, the water is flowing through pipes only. So for a smooth flow as well as a correct pressure, we have to size the pipe. Understood? Pipe sizing is very important. You get a smooth flow with a good pressure. All right, appropriate pressure. Okay, so that is water supply. Okay, we'll be giving to individual fixtures. Now, one connection from the water supply, we can give it to the water heater if you need hot water system. I was telling about the cold water. So in places we need hot water also. So there are different needs to get hot waters. There are different methods. One is you can use individual geysers, or instead of geyser, the other name is you can use water heaters in your toilet. Okay? So anyway, the cold water is coming into your room, into your toilet. So one connection you can take and give it into the one side of the water heater. Circulate, and through the other end you will be getting the hot water, and that hot water we can give it to wash basin and shower. Okay, wherever you are using hot water, you can give it like that. And if you are not willing to give a water heater, you can use another option. You can use solar water heater. So solar water heater means you can keep the solar water heater uh, on the top of the terrace itself. It have in a different, we have different capacities like 100 liter, 150 liter, 200, 250 liter. It can go like that. Capacity goes like that. So you can use that also. So from the top terrace itself, from the main pipe, one connection you can take and you can give it to the solar water heater, and it will flow through that coil, and from there itself you can get the hot water. And you can give it to the individual fixtures. So if you cannot use solar water heater, there are different options like heat pump is there. So in HVAC we will be studying a heat pump. I have already said about heat pump. That is not the heat pump that we are using here in plumbing. Plumbing it's like air conditioner only, and because of the heat pump, it will be you can get hot water. Okay, that is also one of the system, and you can do like that. Okay, and you can do the hot water system. For hot water system, also pipe dimensions or pipe sizing is important. Okay, there is pipe sizing for hot water also. Okay, so we have given this hot water. Now you have to keep in mind is that if the length of the hot water line exceeds 30 meter, okay, we have to give a recirculation pump back to the meter. Why? Because after this 30 meter, if you are not using, what happens is that the water will be stored inside the pipe itself, right? So when you are trying to open the shower, usually you will be getting cold water. Okay, so for avoiding that, this water should be circulated so that every time when you try to open, you'll be getting the hot water. Understood? Otherwise, the hot water will be inside the pipe itself. After some time, what happens? The heat transfer will occur and it will become cold water. So after finishing all this water inside the pipe lines, only slowly it will be starting to get the hot water. So for avoiding that, usually after 100 feet or 30 meter, you have to. It is recommended that you have to give the hot water circulation. Okay. Now we have studied about hot water. We have studied about supply. We have studied about two types of supply. We can do one separately for the flushing purpose into the water faucet, or you can do commonly for everywhere. And the other thing is that we can size the underground tank. Okay? So we are sizing depending upon the number of people. Okay, how many number of people are there, and we'll be looking the NBC National Building Code chart, and we'll be finding out one person will how much water consumption per day per person, and with respect to that, we'll be calculating the overhead tank. And the underground tank will be calculating according to the overhead tank sizing. Okay, we'll be studying it. And now we have studied about hot water also. Then what? After supply, we can just shift to the this was the thing. It's water supply system, it's direct system and pumped system. Pumped system is nothing but instead of you just directly giving to the overhead tank, you can just directly pump from the place locality or from the water source, and you can directly pump into the fixtures. That pumping also is there. So you could call it as automatic pneumatic system. Is there? Auto pneumatic systems are there. Okay. So direct system, pumped system, ground level or underground reservoir sizing or underground tank sizing, elevator roof tank sizing or overhead tank sizing, water pipe sizing in buildings, isometric drawing and preparation. Okay, Morse formula, plumber. These are different formulas for finding out the pipe size. Okay, isometric drawing preparation means there are different drawings for plumbing. Okay, you can draw a plan drawing, you can draw a section drawing, you can draw a schematic drawing. Okay, that is one type of drawing. Then auto pneumatic system designing, pressure tank designing, sizing, garden water supply system. Yeah, another one system we can call it as garden water. So in some cases we will be using STP, sewage treatment plant, okay, instead of septic tank. Okay, in that case, what we will do is that the sewage treatment plant process it and it will be converted into a good water at the end. And that water we won't use it for drinking and all. We can use it for flushing purpose, and we can use it for gardening also. So from the outlet of that STP, we can use a pump and we can give it for gardening. Okay. In the gardening, you can give a, drip connections are there, or drip irrigation is there, and the sprinkler system is there. Sprinkler system. Okay. You can set sprinkler system, and you can use it for gardening also. And after garden water supply system, there is a fountain system design. Fountain, you know what is fountain, right? There is a, water will be hold it, and from there we can spray and different ways. You know what is fountain? I don't want to say anything about it. So you have to say the fountain system designing is there, in the sense you should be able to know the, diameter of the nozzle, the pump, different types of fountain systems are there. Okay, you should be able to know that. Then coming estimation of hot water demand. This is mainly depending upon the how much hot water that we need, and with respect to that hot water, we can calculate uh, the, solar water heater capacity. Or if you are trying to use individual users, we can give what is the capacity that you need, 10 liter, 20 liter, like that. Okay. Then heater capacity selection. Okay. And the flush water and potable water loop sizing. Okay. There are different methods to give pipe connections to the individual fixtures or toilets. You can have a loop connection. You can just give a loop, a round connection from the overhead tank. From there, you can take individual branches from the top itself. Okay. That mainly we can, this it is better for, if it's a flat or an apartment. Okay. We can give that connection like that. Okay. Or from there, a main connection can come. From there, you can split it. You can give like that also. So what I'm trying to do right now is that I'm just giving a brief idea about all these things. Okay. And we'll be doing this in coming classes. What I'm saying right now, we'll be doing pipe sizing, we'll be doing underground sizing, this heater capacity selection. Okay, all those things we'll be doing. Okay, then comes the water supply after the pump, water pump selection, HP watts. So we need to find the capacity, okay, of the water pump. Hydraulic calculation, we have to find the friction loss, head loss, all those things. Okay, and the pump head. So when we are trying to find the pump size, this head is very important, or the friction loss, the height, all those things are come into account when we are trying to deal with this pump selection. Now, then comes the drainage system design. So in drainage system, foul water drainage system design means that, I have already said that, wastewater is there or foul water is there. Then soil waste, water and the waste that is coming from the septic and water closet, that designing is there. Septic tank designing is there. Soak away pit designing is there. Dispersion trenches designing, foul sewer designing, manhole sizing. Okay. Designing of storm water drainage system. Okay, so in drainage, mainly sewage is there, wastewater is there, then soil waste that is coming out from the water closet is there, then storm water, rainwater. These are the main three things. Okay, so just a small idea. Okay, plumbing comes from the Latin word plumbum, meaning lead. Because in initial days, these pipes were once made from lead. That's why we got the name as plumbing. Okay, from the word plumber. Okay, this is just for your information. Okay, so this was the all Roman lead pipe with the fall and seal. All pipes of it, nearly all pipes. Plumbing is the system of piping, fixtures, and equipments installed in a building for the purpose of supply water in the desired quantities at the point of usage, commonly referred as plumbing. Removing of water and waterborne waste from fixtures, equipment, and areas, commonly called as drainage. So instead of plumbing, you can call it as supply, and this as drainage also. So supply water in the desired quantities at the point of usage. That is one purpose. Then removing that water from that, fixtures, okay, is called as drainage. Here it says that the cost of plumbing items generally works out to be 12 to 25% of the total building cost, and in some cases it may be even to 20%. So we are trying to do a building, and construct a building and different areas are there in which 12 to 15% of the cost is coming out from plumbing only. Okay, so it can be even go to 20% also. So that much cost you have to invest in the plumbing. Okay. Now plumbing. What is a plumbing system? Okay. Plumbing includes all the piping and fixtures that provide water for drinking, cooking, bathing, and laundry, as well as a means of disposing of wastewater. Okay. Nothing much to explain about this. Uh, Plumbing can be dangerous, so there are codes that must be followed in order to keep everyone safe. Okay, I was just saying about the code, right? Different codes, NBC, IPC, like different codes are there. Okay, uh, and they have said that plumbing can be dangerous, so there are codes that must be followed in order to keep everyone safe. So we need correct pressure. It should not be over pressure. If you are giving over pressure, what happens? The fixtures may damage it. If you're if you're dealing with pipes and all, some dangers can happen. So a code is a set of rules that can be enforced by a law. So we have to follow that code, right? Proper design. Some of the common codes. These are some of the common codes that we follow. UPC, Uniform Plumbing Code. BOC, a Basic Builders Code. IBOC, International Conference and Building Officials. NPC, National Plumbing Code. SPCCH, Standard Plumbing Code. IPC, International Plumbing Code. ASP, American Society of Plumbing Engineering. And SPC, National Standard Plumbing Code. NBC, National Building Code, etc. So normally you will be using NBC only here. You can use another code also, depending upon what you are trying to design. Okay, so you can use IPC also. Local codes usually adopt all or parts of the UPC or other plumbing codes. Once adopted, codes can be enforced by law. If you want to write this down, you can write this. Sometimes if someone asks you what is a full form of IPC or NDC or UPC, whatever it may be. So Shahil is writing. You can give me a chat, okay? If you want to write this, you can write. Or else I will forward to the next topic. Shahil, are you writing it? Because you are staying in home, those two are working. If you want to write, you can write, or I will send you this video also. Okay, you can write. Once you finish, just give me a thumbs up, or you can just give a chat. If you want, right, I can give you time also. Okay, it's not an issue. Okay, anyways, there are two types of plumbing system. Okay, and we are dealing water supply system and drainage, waste and venting. Normally, we will be calling it as DWV, drainage, waste and venting. Okay. Now, these are the two types of system. So, water supply system, distribution of water under pressure throughout the structure for drinking, bathing, and cooking and laundry. So, this will be under pressure only. Water supply system will be under pressure because we will be using pump and it will be in a pressurized state only. In a two pipe system, one pipe carries cold water and another hot water. So in a two pipe system, one pipe carries cold water and other hot water. Okay, two pipe system. Uh, in a drainage, you know, waste and vent system carries away wastewater and solid waste from bathrooms, kitchens, and laundry. So wastewater is separate and solid waste is separate. Okay, solid waste is the waste that is coming out from the water closet. Okay, so that line is normally we are taking separately, right? And wastewater, you know that the water will be coming from bathrooms and laundries, kitchens, etc. This subsystem is not under pressure. Okay, here we are in this drainage system. It is not under pressure. It must be properly vented to prevent wastewater from entering the drinking water supply. So when we are trying to do this, we have to properly. You should have a vent. You should be vented, and it is not under pressure. Also, it will be flowing by the help of gravity. So when we are dealing with the drainage, okay, we need slope. So I have just shown you a AutoCAD file, and I have shown you the slope. I have written a slope 1:200, 1:50, like that. So that means that there, because this water is flowing not under pressure but under gravity. So in order to, for a smooth flow, we have to give a slope. Okay, we have to find out the slope. It depends upon the type of different diameter size and its length. Okay, and we have to give the slope. Now, the plumber's tool belt is just a small idea. Okay, the plumber's tool belt carries many of the same tools in carpentry and electrical work. Simple plumbing tasks only require a few tools, mostly commonly a wrench, while larger plumbing jobs use a variety of tools. So the plumber's tool belt includes wrenches and other tools used to measure, align, and mark cut. Okay, trim and thread. So this is just for your idea only. The plumber has a tool belt in which we have many other tools. So a few measuring tools are, these are some rulers, measuring tape, L-square, etc. Alignment tools are, levels, plumb bob, okay. Then marking tools, pencil, compass, etc. Cutting tools, chisel, files, etc. Cleaning and threading tools used for work on metal pieces. Cleaning the end of a pipe removes the burrs caused by cutting. So, mainly when dealing with metal pipes, the end it will be very smooth, not very smooth, very sharp. So we have to make it smooth by help of cleaning and threading tools. Now different wrenches are there, adjustable wrench, pipe wrenches there. Different types of pipes are there. Okay, this is important. Okay, we will be having different types of pipes. Okay, these are the different types of pipes that we will be using in our plumbing system. So I want you, if you have time or if it's possible, if you want to write this is important. Okay, you can write this down. These are different types of pipes that we will be using in plumbing. Okay, according to different application, we have to use these pipes. Last time will be there. Polyvinyl chloride PVC pipes are there, and where we are using these PVC pipes, it's been written there. Sanitary line, vent and drain pipes. ABS, acrylonitrile butadiene stearine pipes are there. Sanitary waste lines, vent pipes and drain traps they can use. Then UPVC, okay, cold water supply system, and sanitary waste you will be using UPVC. So mainly for cold water supply, we will be using UPVC only. Okay, and hot water we will be using CPVC. But nowadays, CPVC, chlorinated polyvinyl chloride, is used for both hot water as well as cold water. Then plastic supply piping, pipe, is there. PX, cross-linked polyethylene, water supply, black iron materials is being used for gas supply, copper pipes are there for water supply, galvanized iron materials are there for water supply and drain. So if you want to write it down, you can write it down. I will give you time. Once you finish, give me a thumbs up. Okay. Mainly we'll be using this UPVC and CPVC, and for drainage we'll be using PVC. Different standards are there for this, and different measures are also there. Okay, 4 kg, 6 kg, like that is there, and the different thickness are there for the schedule 40, schedule 80, like that. We'll be studying, okay, in the coming classes. This is very important for engineers also. Okay, if someone asks you what type of material that you are using for this cold water, hot water, drainage, etc., like that, you should be able to answer it. Okay. You completed? Okay. So these are the different pipe materials. Okay. Just for your understanding only. It's fresh water. If it is inside water which is flowing through the pipe is a fresh water, or it's a salt water. You can use these materials. Wherever it is been picked, you can use that material. Last time you can use for cold water as well as hot water. Salt water also with internal cement lining should be there. Okay. Fire service. Okay. You can use fresh water as well as salt water. These are different standards. Okay. Of cast iron. The same way with copper and with GI with PVC cotton lining. Okay. PV pipe. If it is shown cross, which means that you cannot be used that. Wherever it is been picked, you can use that. Okay. So when you see the video again, you can just configuration of it. Different PVC, chlorinated PVC, CPVC, you can use it for hot water as well as cold water. First, anything you can't use it. PVC, you can use it for cold water as well as salt water. Okay. Yeah. These are internal toilet piping for water. Okay. We can have exposed pipes as well as concealed pipes. Normally, we won't have an exposed pipe lines. We'll be having only concealed pipes. Concealed pipe means the pipe which will be flowing or which will be taken through the wall only. We won't be able to see the pipe connections. Okay. So exposed pipes you can see like this, exposed piping. The pipes will be exposed like this. Nowadays it is not used like that. We cannot see our pipes inside the toilet pipe. It's concealed. So exposed pipes are usually metallic pipes like GI, SS, and copper pipe, etc. Right? Because it is associated with the problems are external corrosion, heating of paint, hot water supply in pipe, fixing with SS clamp and screws. Okay, because it is it is mainly dealt with corrosion and all. We have to have you know metallic pipes like this. And occupies the storage space on the wall. Efficient labor is required. Costing is also higher. So we will be using mostly we have to use with concealed pipes only. Maybe any pipe with GI, CPVC, PPR, composite, etc. like that. Any pipe material can be used depending on the availability. The arrangement become monolithic after embedding in wall. Costing will be lower depending on the material of construction. So mainly will be concealed pipes only. Okay. So these are the different postings. Okay, which is given. Okay, internal toilet piping. Okay. And this require SS clamps, high quality enamel paint require. So what and all will be okay for this and 26 pipe post depending upon different diameters. It's been shown here. This will change, okay. For GA pipes, this is the thing. For composite pipes, this is the posting. For CPVC pipes, cost is different. Okay. And its advantage is also given as well as its brief description is also given. So just you need to go through all these things. Okay, not explaining much about this. These are different pipes. Okay, UPVC pipe, PPR pipes, EA pipes. Its costing is given. Okay, it will change. Okay, depending upon the market value. Okay, and its advantage is also given in the side. Okay, durable, economic, and durable. Okay, easily corrosive or burned pipes. That's an advantage and disadvantage is being shown there. So these are the different sewerage layout, piping connections, etc. How they are laying it. Okay, there will be a manhole. Okay, this manhole is used for inspections and access. All those things you can have it. Okay, this is the sanitary line. It can be given into the different main pipe, and you'll be having a manhole Okay. This is the rainwater pipes you will be getting from your rain from your roof catchment areas. It will be going with another stormwater pipe. Okay, those are the important things. These are all about different pipes only. So some important things. These are the different pipe diameters that you need to know. Okay, these are important. Okay, so nominal pipe diameter. Okay, nominal pipe diameters of supply pipes are okay, normal pipes. You have 15 mm, 20 mm, 25 mm, 32 mm, 40 mm, 50 mm, 65, 80, 100, 125, 150, it goes like that. So normally these are the pipe dimensions. If you ask for 16 or 18 or 21, you won't get it. So after 15, it will be 20, then it will be 25. Okay, it goes like that. So these are the normal pipes. Okay, uh, when it comes to the copper pipe, you have 15 mm dia, then it comes 22. Okay? When it comes to copper pipe in dia in mm, you have 15, 22, 28, 35, 42, 54, 67, 76, 108, 133, and 159. These are the sizes of copper pipes. UPVC, unclassified polyvinyl chloride pressure class pipes are 15, 20, 25. These are normal pipe size of this. Okay, these are normal pipe size. The same with polybutylene, but it starts from 20 only. There is no 15 mm pipe. Then it comes 25, 32, 40, 50. After 50, instead of 65 it is 63. Then 75 is there. Then 90 is there. 100 is there. 125, 150. Then cross-link pipes, you have only 20, 25, and 32. The rest is not available. Polypropylene pipes, you have 25, 32, 40, 50, 63, and 75 till 110. Rest it is not available. Then MS pipe, normal pipe dimensions is given. Okay. So these are the equivalent pipe diameters. Okay. So when you are trying to give some pipe dimensions, it should come in between this. In between this means you have to opt these pipe dimensions or diameters. You cannot go for 61 or 68 or 70 like that. Okay. Then pipe sizes for connections to sanitary fixtures. Okay. What does this means is that different sanitary fixtures are there now in our toilet and in our kitchen and all. So minimum pipe size or minimum for this should be the pipe size to this particular fixture. Okay, the main pipe can be different, but coming into the specific like water closet, wash basin, the entrance pipe dimension should be this. Okay, so let's see water closet with crystal water closet with a flush water both. Or you want the hot water connection to the water closet, so it is not there. So you can give 15 mm. So minimum pipe dimensions is 15 mm to the water closet. But usually what we do here is that now as as the law you can give 15 mm pipe size, but usually contractors won't give 15 mm. They will be just directly giving 20 mm pipe. They won't go for a minute, a very small pipe. 15 mm is very small pipe. As per the NBC and all those things, 15 mm is enough. Okay, fine, you can go. But as a safety factor, even though if we try to give 15 mm, the contractors will sometimes they will be doing whatever that we are trying to decide. That should be the case. But in some cases, instead of 15, they may give 20 mm pipe. Okay. So it's not necessary that you have to give 15 mm. As a rule, you can give 15 mm, but still, when they are commissioning or when they are trying to place it, instead of 15 mm, they usually give 20 mm. 20 mm pipes. Okay. Then flush valve means we are not having any piston. Okay. So that means there won't be any tank. Okay, for water closet. We will be having a flush valve only. In that case, this will be called water. We have to be 40 mm pipe. In wash basin pot as well as pot, we can be 15 mm. Each ablution hose normal hose, you can give 15 mm. That you can give hot 20 and cold 20, shower 15 and 50, violet 15 50, kitchen sink 50, washing machine cold you can give 50, dishwasher 15 50, urinal 15, urinal with the flush valve 32. What is this? Cleaner sink you can give 50. Okay. These are the minimum pipe diameters that you have to give. Then pipe sizes for connections from sanitary fixtures appliances shall be as follows. Okay. Now sanitary fixture. This is the drain pipe. We were talking about the supply pipe only. Now we are talking about the drain pipe. So supply pipe will be 15 mm, 20 mm like that. From the water closet, you will be taking the waste outwards, right? So the minimum pipe dimension for water closet should be 110 mm. Okay. Wash basin 32, shower 40, bathtub 40, washing machine 40, mirror 32, kitchen sink 40, urinal 32, cleaner sink 40, floor trap outlet it can be 82 or 100. So this can be differ. A minute difference can happen depending upon different types of cord you may use. Or a UNO like cord, like you can use this. For MDC it may be different, but this will be all same. Okay, water closet it will be minimum, it will be 110 only. But there will be a small difference in case of IPC and NPC like that. So what you are trying to choose, you can follow that cord. Now the slope, we have talked about the slope. So I have mainly said that the slope depends upon the diameter of the pipe. Okay. So these are the different diameters: 200, 160, 110, 80, 250. It goes like that. So the pipe dimensions or diameters differ. According to that, the slope also differ. 1:120. So 1:120 means in 120 meter, for example, if the length is 120 meter, the slope will be 1 meter. So if the length is 120 centimeter, the slope will be 1 centimeter. That is 1:120. In the case of 160, for 90 meter length, 1 meter will be the slope. For 32 mm, for 30 meter long, 1 meter will be, its slope. Okay. So when the diameter decreases, the slope also will increase. So it is 1:30, 1:40, 50, 1:120. And the size is large, the slope can be less. Okay. This is just shown of the hanger spacing, how much should be the maximum horizontal spacing. Okay, for different pipe material, and maximum horizontal spacing and maximum vertical spacing. Okay, so how to give the hanger, how to place it, after how much feet you have to do the next hanger like that. Okay, there's nothing much to know about this. Now, these are the different pipe fittings and its parts. Okay, 90 elbow is there, 1/4 bend is there, thread coupling is there, CPVC T joint is there, double T is there. This is for different fittings only. Okay, bushing, union, okay, male adapter, PVC clean out, okay, PVC cross. These are our fittings. Okay, if there are four pipes coming closer to each other, you can use this PVC cross pipes. Okay. When you have to use T, you can use T. Okay, these are different pipe fittings and its parts. These are closet flange is there, ABS cap is there, you can have cap. Heat trap is there. Okay. Pie joint is there, brass coupling, brass cross coupling, or cross joints. Floor flange is there, brass bushing is there. These are different, wide joint, double wide, copper cross, nail and after. These are different fittings. Okay. Now, okay. Now I'll show you another thing. What's the difference between a valve, a fixture, and a faucet? Okay. Let's see what's the difference between a valve, fixture, and a faucet. So just think about it. Can you give me an idea what you mean by a valve, a fixture, and a faucet? Okay, anyway, I will explain. Yeah, valves. You can see these valves here. Under the wash basin or head of the water faucet, you can see valves like this. You can just rotate also. So what do you mean valves are? Valves that control the flow of water in the water supply system. Okay. They are installed at certain places on the line so that the water can be shut off easily. So if you want to shut off the water connection from here to your water faucet system, you can close it here. Okay, if there is some maintenance and all, you can close it here. This all the water won't be flowing from this pipeline to this. Now, what do you mean by faucet? Faucet is when there is a wash basin, there is a faucet. Okay, it can be a mixture also. Okay, there is a hot water as well as cold water like that. If they push up, there's a mixture also. But faucets directly means like a tap. Okay, you can see this. You have seen this thing, right? Have a plot in wash basin, you have seen this. So valves that permits, this is also a type of valve that permits controlled amount of water as needed in a building. They deliver water to sink, showers, and bathtubs, but can also deliver water to hose. So these are valves that permit controlled amount of water as needed for using a building. Okay, you have seen this. So different types of valves are there. Deep pop, this is like a tap, deep pop. Okay? You have seen this deep pop taps. Stop pop, you can close the water flow towards this side as well as this side. Okay? The stop pop will be given in toilets, okay, in the initial stage of toilets. You need to shut the water supply to the particular toilet. You are just closing the stop valve, stop pop. You can stop the water supply. Okay? That is known as stop pop. This angle pop is also like a valve. Okay? Stop it and open it. The finger pop. That pop. What will be coming to this? This is a ball pop or a pop. This is mainly in the piston. Water closet. There is a block valve. Not only that, in the municipal water connection, or a ball pop. When the water level is to a proper level, this will shut. And it will come up. We are able to rain next way. Water valve. You can't hear anything. So anyway, let's see this. See this, okay? Outlet. Can you hear right now? Because here it's raining, so is it possible to hear right now? Hey, what is it? Is someone speaking? I cannot hear. Am I audible? Am I audible right now? Okay, anyways, yeah. So we just this is are some of the animated videos, okay? Animated setup of different bags, okay? Different bags that we are dealing with. Now, so these are fixtures, water using devices such as sinks, bathtubs, urinals, stools or showers. We could call it as fixtures. Okay, they are attached to the plumbing systems and receive water from the supply systems. Okay, you know what is this fixture? So we were dealing with what do you mean by faucet, valve, and fixtures, right? So, so this is just a question. Can you correctly? Is this is correct? This is a valve. This is a faucet. This is a fixture. Is it correct? Is it correct? So, so my question is it a valve, faucet, and a fixture? Whether this is correct? Uh, is it possible to hear right now? Yeah. So I am asking that whether this, is this a valve, is this a faucet, or is this a fixture? Are these labeled correctly or not? No. So can you say what is this? First, second, and third one. You can just write it over there. Fixture, valve, fixture, valve, faucet. No, it's not correct. Which what is this? What is this? What is in the center? What is in the center? Is this a faucet or a valve or a fixture? The center one. No, that is not faucet. I am asking that this is not correctly. No, are these labeled correctly? You said that it is no. It is not labeled correctly. So you are saying that this is faucet itself. So we were dealing with what is faucet, what is valve, and what is fixture. After this, when you say this, you cannot say what is a faucet or fixture or valve. So I will show you the correct answer. No, the correct labeling is this. Sorry. So the correct labeling is this is faucet, this is valve, and this is fixture. Okay. So this is the correct labeling. Okay. Now, I think there is nothing much. Yeah. So these are some of the when you are trying to build when you are trying to give water supply. This is a handicapped toilet only. Handicapped. So disabled toilets is there when you are dealing with some auditoriums or hospitals or something like that. There is a provision for disabled toilets also. Okay, so when you are trying to give disabled toilets, the height where you give this water supply and drainage, everything will be changing because there are some difference, right, in the handicapped toilets than usual toilet. So these are the some of the dimensions have been marked here. 1750 mm minimum or 1675 mm width of most compartment. Okay, and it should be normally it is more than 1520 mm this width, and this length will be 1370 mm minimum or 1520 mm where depth is less than 1750 mm or door in alternate position. Okay, so minimum it should be 1370 mm this width also. Okay. So or 1520 mm where depth is less than 1750. So when the depth is less than 1750, you can use 1520. Okay. Or door in the alternate position. Okay. If door is there also, you have to do like that. Then this is the paper or towel dispenser. This is the basin rim, wash basin rim, and it is at the height of 780 mm above floor. Now rail at 280 mm above seat. This is the rail because you need some rails because these are handicapped persons. So horizontal polarity. So that is this. Now water closet at 500 mm above floor. Then there should be a vertical rail. 835 mm to 1295 mm above floor. Then this length should be 19965 mm. This length should be 255 approximate from this center. Then from this to this, it should be 760 mm minimum. So these are some of the dimensions. Okay. Then coming with the, when you see a disabled toilets, it will be like this. Okay. So it should be like this. So a disabled person should be able to enter into that, water toilet, and should be able to, do his part by sitting in the chair itself. So according to that, we have to set it out. Okay. So these are different toilets for disabled toilets. Okay. So these things will be, may be given for disabled people. So okay. Now, so these are the most some of the common things that that we need to understand. So today I have taken only, uh, a, an introduction regarding this plumbing system. So just I will give you a brief idea of what we have studied today. So basically, this plumbing, we have the supply and drainage. And in supply, we have main supply also, that is from the well and the underground tank to the overhead tank. Now, from the overhead tank to the individual fixtures, we have water connections, pipe connections. That pipe connections has to be, designed in a proper pipe diameters, and there is flush water, there is a domestic water supply, there is hot water supply. Hot water also there is pipe dimensioning is there, pipe sizing is there, and hot water, we have to calculate the capacity of the hot water, tank. Is a solar water heater or individual geyser. Then we have studied about, we have solid waste is there, wastewater is there, then storm water is there. So we have studied about minimum pipe diameters that we need, and we have studied about the pipe diameter for the supply also. Minimum pipe diameter for the supply also we have seen. We have seen different materials. We have seen different types of pipes. Okay, why we are or what this type of pipe we are using for what, we have seen that. We have seen different pipe dimensions, standard dimensions we have seen. Okay, and okay, these are the important things that we need to study. We just gone through the pump capacity HP or in kilowatt. Okay, then we have seen about if there is no pressure, we have to use booster pumps or pressure pumps. Okay, we have seen like that. Then just imagine like this: water source is there. From the water source, you have to pump it to the overhead tank. From the overhead tank, you have to give it to the individual fixtures. Okay, and if there is an overhead tank, there will be an underground tank also for storage. For example, why do you need underground tank is that in case something happens and if your motor is not working properly, and there is no sufficient water inside the overhead tank. For a safety purpose, you should have at least a 3-day storage as in the underground tank. Understood? Okay, so that so in such way also we can have underground tanks. Then we have just seen about when we are trying to give water supply. Uh, can give the water supply for gardening purpose also. So sprinkler systems are there, drip irrigation systems are there. All this comes in plumbing. Okay. Then coming to drainage, there are different tank sizing. There are septic tank sizing, soft away pit sizing is there, dispersion trench sizing is there. wastewater pit sizing is there. In some cases, in big auditoriums and in big flats and all those things, instead of septic tank, they will be using STP, sewage treatment plant. Okay. So, depending upon the number of people, sewage treatment plant is there. Okay. And that sewage treatment plant water can be reused mainly for flushing as well as for gardening purpose like that. Okay. So, tomorrow we will be studying about mainly about the different important topics. Okay. So today, just for your idea, just I have just shown you, uh, you know, or I have just given a brief introduction about this plumbing. So we have seen different standards and codes. Okay, that is also very important. So we have to follow the standards and rules, and, we need some approval. So when we deal with that, when we go through with that standards and rules, then only we'll be able to, then only they will be giving the approval also from the local authority. Okay? So that also you have to keep in mind. So this is just a brief introduction. Okay, I think we just had a small idea about this plumbing and all those things. So for the time being, we can just stop here. And tomorrow we can start the new session. Okay. So is there any doubt regarding today's topic? Is there any doubt you can ask me? So you guys understood what I have said today? Is there anything that you need to know? So most probably, I don't have time in the evening. Tomorrow only, sometimes I may send you this link today itself, or tomorrow morning I will send you the link, okay, of this class. So thank you, students. Thank you. So we can see you tomorrow.